So my team created an EOG device. This is a device that helps people communicate via blinking to help people with severe disabilities to communicate. And we worked with a company named ThoughtWired who works with these customers. So your eye is polarised, and when you blink, you let off an electrical pulse that you can pick up on the forehead region, and that's what we're really trying to do. We're trying to pick up on that blink, and we're going to use that as a control mechanism with software.
When you blink, the potential difference that gets created is picked up by our circuit, and as you can see on the plot here, there's a frequency change, and this represents a blink. So the signal going up and down is one full blink of your eyes opening and closing, and the serial plotter allows you to see that in real time.
ThoughtWired does access technology for people with severe disabilities. This is an off-the-shelf headset. Here we have quite rigid electrodes on a person's head, which can be very uncomfortable for a user, especially a user with cerebral palsy. It doesn't take into account that a person might be in a wheelchair and will have a headrest. What they've found with those off-the-shelf headsets is that they've got some limitations, and ThoughtWired really wanted to bridge these limitations.
So in this project, we collaborated with the Textile Lab from AUT, and what they did for us was that they created this textile electrode, which we used for our prototypes. This material in the middle is a conductive material which goes on your head. The reason for this cover was to ensure that the user can maintain their headset, so they can take it off and wash the cover and put it back on, whereas with the existing headsets, they don't have that capability at all. This is our final prototype, and we have two adjustable points on either side of the headset. So you put it on and tighten it once, and the elastic back strap allows you to slip it on the next time you want to use it. We've also got the electrode signal from here, and this along with the ear clip, they both work together to help us identify the blink that comes through.
We had to go and we had to research a lot, but we also had to go and pick up a lot of new skills. For me, one of those skills was creating a PCB, which is a printed circuit board. I had not done this before. I had to use a new program, I had to design circuits, and had to even fabricate the PCB myself and then test it.
One of the things that I worked on with this project was to write the code to take the analog signal from the PCB and convert it into a digital signal so that we can use it for digital processing and filtering. So what that involved was encoding it so that when we transmit, and if it gets corrupted along the way, we have that ability to detect that corruption and we can discard that data.
So this was quite a task, but a worthwhile challenge. To unleash potential of the most vulnerable people is like such a beautiful thing, so we wanted to be a part of that.